Good day, guys. This is your tutor engineer. Welcome to another video on Euclidean geometry. So don't forget to subscribe and to like this video. So let's just get into today's lesson. Okay, now we have a PT as a tangent. So they say PT is a tangent to a cyclid T. Okay, here is point T. You can just, that means basically they're giving you the information that this angle here, tan chord theorem, is equal to that angle over there. So if that is y, this will also be y, and the same goes for this angle here, will be equal to r1. Okay, so then they say PR and TS are parallel. So you have PR, then you have TS. So that will also mean if R2 is y, that means T3 is also going to be y by alternating angles. So that is what maybe you can take from that. And then when you continue, it says PQR is a straight line. Then QR and S are points on the circumference of the cycle. R2 is y, angle S is x. QR and TS are equal. So QR is a chord. It's equal to another chord, TS. So that means here, R, which is subtended by chord TS, would be equal to T2. I'm just going to put a double pink line on T2 because it's also subtended by the equal chord TR. So I think we have a picture. We have simplified our diagram. Now it's easy. It's gonna be easy to answer the questions. So let's look at the first one. It says name two angles, two other angles, each equal to y. I think we've labeled the diagram already. You can see that we have labeled T3 as y and T1 as y. So just need to provide the reasons. Remember what we said about T1 is equal to y. We said the reason was tan chord theorem, right? Because it's equal to R2, right? So the reason is tan chord theorem. Okay, and then for T3 is equal to y, it's equal to y, right, because of alternating angles with R2. So that you'll say alternating angles are equal. Remember, they gave us that PR is parallel to TS. And then, yeah, that's the first question. That's 4 marks. Then the second question, determine given reasons another angle which is equal to T2. You've already labeled T2 as a double pink. So we said it's equal to R1, if you remember. So this is number 1. Okay, now I'm doing number 2. So we just say here T2 is equal to R1. The reason for that is those are angles subtended by equal chords, right? So you'll recall that QR is given as equal to TS. So angles subtended by equal chords are equal. Then let's do the final question. Number 3, prove that TR is a diameter to a cycle. So here is TR, it cuts across the cycle. So if it's a diameter, there are 2 possibilities to prove that. We can either prove that X is 90, or we can prove that Q2 is 90. That would be the angle subtended on a semicircle. Or we can prove that this angle here, T3, and this chord tan theorem, sorry, this chord tan angle at the bottom is equal to 90. Or we can either prove that that these T1 and T2 are 90 degrees, because that would mean the diameter is meeting the tangent at 90 degrees, right? So we're going to use the converse of that. I think it's going to be easy. Let's look at T1 and T2 already, since we've already spoken about it. First of all, let's find out the size for angle T2. Remember, we said T2 is equal to T1. is equal to R1. I beg your pardon. If we can find R1, then that will be the same as T2. So we can say here, R1, we can realize that it's in the triangle RST. R1 plus angle S plus angle T3 is 180 degrees. So those are sum of interior angles of triangle. Then R1, the replacement angle S is X. T3 we said it's Y, that's 180. So that means R1 is the same as 180 minus X plus 1 in bracket. So that's the same as T2, right? Because R1 is equal to T2. And then the next thing we can do, if you can prove that X plus Y, if you can prove that T1 plus T2 are 90 degrees, then we have provided the proof that TR is the diameter to a cycle. Because you know for sure that PT is a tangent that is given to us. So the next thing that we can do, right, to find T1 plus T2, you'll recall that T1 plus T2 is equal to angle X. So that's tangent, and then that's a chord. For now, we're going to treat TR as a chord. So the next thing, we say T1 plus T2 are going to give us angle S, which is S. So we're going to say tan chord theorem is a reason. So that will mean T1. Let's just do a replacement. T1 we said it's Y. T2 we've just worked it out. It's 180 minus X minus Y. Then angle S is X. So now, okay. Now I'm just going to take X and Y on one side. So first of all, the Y will cancel out, right? And then if I take the X to the other side, it will be 2X. Remember, this moves to the side, it's going to be X plus X, then it's 2X, and then we have 180. Then you divide by 2, you find that X is 90 degrees. So that means that angle there is 90 degrees. Okay, so that means that's the angle on the semicircle. So that should be the proof. Therefore, let's make a proper conclusion. Therefore, TR is diameter. That is the converse of angle on semicircle is equal to 90 degrees. And that's it. That's it for today. So stay tuned on another lesson on Euclidean geometry. Don't forget to like and subscribe. Cheers.